What's going on, everybody? Welcome back to another episode of Triangle Diagnostics. Today we are working on a 2004 BMW 325 Ci that has a 2.5 liter engine equipped. You may have seen it in a previous video dealing with an oxygen sensor fault code. Same car, we're addressing a different issue with this one. The issue we're going to be dealing with today, guys, is a 2772 fault code. Sort of the code description for that is fuel tank ventilation valve. Not too good with BMW, but I'm fairly sure what they're meaning with that terminology is something related to the Purge Solenoid. I believe it is a Purge Solenoid open circuit fault. So that's what we're going to be addressing, guys. So first step for us, let me get you the scan tool. Let me show you the fault code I'm talking about, and then I'm going to pull some information up on it so we can get a little bit of a better idea as far as code set parameters and wiring, some other, particular stuff like that. So let's get going. So I'm just in the Varus here, guys. I've just got these codes pulled up. The one we're going to be focusing on I have highlighted here. Again, it's a fault code 2772, fuel tank ventilation valve. So that's going to be the one that we're going to be going after here, guys. So next, let's take a look at some information for this fault code and determine the best method as far as troubleshooting it. All right, guys, so I took another look as far as description, operation, code set parameters, and stuff like that of this. And indeed, the valve that it's referring to is, in fact, the Purge Solenoid. This is an open circuit type fault, guys. So really what this engine computer is looking at is it's looking for 12 volts on its control side terminal on the engine computer. This is a ground side switch solenoid. It is fed 12 volts all the time from a fuse, or excuse me, not all the time. It's going to be off of a relay, but it's fed 12 volts, and it's going to be ground side switched. So basically, guys, this fault code is going to set when the engine computer does not see 12 volts at that control terminal on the engine computer connector. And really that can indicate an open circuit. It could also indicate a short to ground on this ground side control wire. What we're looking at here, guys, just a diagram. And to make it real easy, the area we're focused on is here. They're calling it an evaporative emission valve. It's located on the left front of the engine. We can see that it has two wires going to it. We have a red with white with yellow. That's a 12 volt feed. And then this other wire coming off it, that's a brown, that goes straight to the engine computer, and that's going to be the ground side control of this. So as far as first steps goes, guys, we need to locate this Purge Solenoid and really start doing some checks there. One thing we could also visit too, and that's probably going to be pretty critical on the diagnosis, is let's see if we have any functional tests on the scan tool first. If we do, we'll then go locate the valve and start doing some testing. So again, guys, I just want to see if we have any functional tests available for this Purge Solenoid. That's really going to assist us in doing control checks at this solenoid to make sure wiring integrity to the engine computer is good. So I'm just going to click on functional tests here. I'm betting money on actuator tests. And I'm just looking down through this. And it looks like we have this tank vent solenoid valve. I'm not sure what that is. I'm going to click on that. See, I'm a little bit worried that this may be the canister vent valve. I'm not 100% sure, guys. Seems to be loading this test up. Again, not exactly sure what we're going to find in this test. It appears nothing. Oh, there we go. It has this tiny little start key. So it looks like this is doing this on a timer, guys. It's not going to be super helpful. One thing I can't say is I don't really hear anything clicking on the vehicle at all. Maybe this is some sort of countdown. We'll wait till it counts down to 0 and see what happens. So we counted down to 0. I didn't hear anything on the vehicle happen. I doubt you guys did either. I'm not certain if this is going to be the canister vent valve or the Purge Solenoid. I'm also not exactly sure what sort of evaporative emission system this is. I'm not sure if this is a key on or a key off system. It may not even have a dedicated vent valve, and may be using some form of leak detection pump to perform its evaporative emission sealing. Not 100%, guys, but just moving forward, I'm going to go back to this functional test menu here just to see if we have anything else. And truly it does not appear that we do. I'm going to go to the special functions maybe. We do have this evap diagnostic module. System actuators. We have that same test, tank vent solenoid valve. So not 100% what this is, guys. Not sure. I think first step, let's just go to the car. Let's locate this purge solenoid and kind of familiarize ourselves with it next. All right, guys, it's going to be a little glary. I had this light down here. But I've located the purge solenoid and kind of where it is. You got to pull the air box out to see it. Let's see if I can focus in on that. It's this guy right here, this connector. You can see it kind of plugging in right about here. So this connector has this sort of shield on it. We can see the wires coming off on the bottom side of that right there. So what I'm going to do, guys, I'm going to get you guys propped up. I'm going to unplug this, potentially get this cap off and get a T-pin inserted here. And we'll just do some initial voltage checks at this location and see what we're working with. All right, guys, this is probably going to be the best shot I can get you. As we can see here, this is our purge solenoid. All I've done at this point, guys, I've just unplugged it and I pulled this little protective cap off of here just so we can inspect the wires. As we can see, we have a brown wire going to this. We also have a red with white and yellow dotted going to this. So, this is definitely the right connector here, guys. Remembering our diagram before, this red with white with yellow, that was our power feed. This brown one was our control. So there's a couple different methods we can use to test this. One method we could use is we could just rig up a Noid light in here and we could confirm wire integrity that way. But then again, if this were some sort of intermittent fault, probably not the best test. Really what we want to do is we want to positively identify a fault in the system. Another test we could do, we could also do a resistance measurement here. We could also do some current ramping stuff. I think as far as a good first step, let's just get a test light on here, guys, and let's make sure that our feed to this solenoid is good. That feed would be on this red with white and yellow wire. So I'm just going to grab a test light, make sure our key is on, which it is currently not, so I'm just turning the key on here, guys. Get my test light hooked up on a known good ground somewhere. A little bit easier said than done on some of these European vehicles. Pretty much everything's made of plastic. So my test light is lighting. I just checked it over here on the jump start terminal. So again, guys, what we're looking for here, we're looking for our test light to light on this red with white and yellow. As you can see, test light is lighting. Pull that back off, put it back in. Again, I'm not stuffing this in here, guys. Definitely not stuffing this in here. So we definitely have our feed there, guys. So at this point, really what we're worried about is control to this. A couple of different methods we can use to determine if control is present or not. I think the easiest thing to do is let me get a Noid light put in this thing, and let's revisit the functional test that we had on the scan tool just to see if maybe it is in fact energizing this vent solenoid. So I'm just grabbing a Noid light, I'm grabbing the scan tool. Realize there's going to be a little bit of glare here. This shot's probably not the best. Hopefully you can still see, this is the connector we're dealing with here, guys. So all I'm doing with this Noid light is I'm just substituting the load in this circuit with this light. I'm going to attempt to get this set up somewhere to where it'll kind of stay and not go anywhere and not short together either. Let me see. See if I can do it like that. That may work. That may work just like that. So let me actually turn this light off at this point. So if you guys can see where I've rigged that little bulb up there. So I'm going to go back to this tank vent solenoid valve functional test. And I'm going to see if this is in fact our guy here. So I'm just hitting continue on this test. I realize you can't see the scan tool. Let me get it down here to where you guys maybe can. Sort of trying to wedge it in here. You know what? Maybe I'll that should work. Should be a pretty decent shot, guys. I'll turn that hood light off. Maybe you can see the scan tool, not really important. What we're mainly focused on is this bulb here that I've rigged in here. I'm just going to hit start on this test. And really what we would want to see here is we want to see this light flashing. But again, with this functional test, guys, we don't really know if this is even the correct test or not. It definitely does not appear to be the case. I don't hear anything going on in the back of the vehicle, and we definitely don't see this lighting. I'm just going to make sure that my connections are good here. You know, again, guys, with this fault code, you know, we could very well have an open circuit on the control side. You know, we're not worried about the feed side so much, really just based off of the fact that we definitely had voltage from this fuse here. I'm going to do this test one more time just to make sure, holding these terminals in here, they feel nice and tight. Absolutely nothing there. So again, guys, probably not the right test for this, but it was worth a shot. The next easiest thing we can do, given that we do not have any sort of bidirectional controls, at least ones that are clearly for this thing, is let's simply do a resistance measurement through this solenoid and determine what sort of resistance value we're looking at. I don't really have a specification for this, guys, so we're just going to be kind of winging it. I know what I'm definitely not looking for. I'm definitely not looking for an open circuit here, you know, without a doubt. Remember our fault code, guys. Open circuit type fault code is what we're dealing with here. So really, if this purge solenoid has failed, we're going to see some sort of, you know, absolutely wild resistance number. It's also possible this is only, you know, a heat-related failure. It may be possible we're going to need to warm this vehicle up. Not sure yet. I'm just thinking about, you know, the easiest way to troubleshoot this with limited functional tests. You know, really just somewhat limited in what I can do with this vehicle. So all I'm doing here, guys, I'm just doing this with a plain Jane multimeter. Hopefully get this focused up for you guys so you guys can see this pretty well. See if I can get it propped up. A nice easy location for you guys to view. It might be it right there. Let me turn this light off. It's not working too well, is it? Let me turn this backlight off. Turn this light back on. So not sure how well this is showing up, guys. It's gonna be, you know, the lighting in here is pretty terrible, for sure. Let me maybe get some more lighting in here from the bottom. That's gonna have to work, guys. So as you can see, currently we have OL in our meter. I'm just touching these together. See a measurement on the screen, 0 ohms. So all I'm going to do with this, guys, is I'm just going to go between these two purge solenoid terminals, and we're going to see what our solenoid resistance is. So I feel that I'm making pretty good contact in there, guys. What I'm currently seeing on here is 850,000 ohms. We're currently on a mega ohm scale. Our readout is 0.88 currently, kind of floating around that 0.85 sort of range. And remember, on this mega ohm scale, guys, really what that means is 850,000 ohms. You know, really just with that, guys, this purge solenoid is bad. No doubt about it, high resistance. I'm not exactly certain on a resistance specification for this particular solenoid. And, you know, to be honest, I couldn't really find one anywhere either. But typically when you're dealing with, you know, a solenoid like this, you're typically going to be under 100 ohms, most likely. I'd say ballpark, maybe 10 to 50 ohms on average is what you're going to see on a typical purge solenoid like this. I'm not 100%, guys. Again, do not quote me on that. But what I can tell you for certain is that at 850,000 ohms, this is a high resistance solenoid, no doubt. And this is where our issue lies. I'm going to attempt to get one coming so we can do the fix. And while we wait for that, I want to explore some methods in testing this control circuitry, given that we do not have any functional tests on the scan tool, just to see what we can come up with for the future, you know, in case, you know, we do have an issue on this control wire. So let me figure out what to do about that, some tests we can potentially do on that. And yeah, we'll film that and have a little discussion about it while we wait for this purge solenoid to show up. All right, guys, so as far as exploring our options here and how we can get this PCM to command this purge solenoid on for us, so we can double check wiring integrity back to the engine computer on this control circuit. What I've done here is I've just went back to the special functions tab under functional tests here. And I'm looking a little bit more into this evap diagnostic module test, and I'm just going to scroll through some of these. Yeah, we can see this uses a leak detection pump for sure. Just kind of reading through this. So kind of reading through this, guys, this is definitely appears to use a leak detection pump. I'm kind of reading this top line here. It says, in its inactive state, filters fresh air through the evaporative emission system through the sprung open valve of the pump. I guess what that sort of implies, guys, is this leak detection pump is kind of pulling double duty and sort of functioning as a vent valve in this circuit. Taking a look at some of these other options we have here, guys. Really, I'm just looking for any sort of way to get this engine computer to run this purge solenoid for us. Because really, if we didn't have a high resistance solenoid, guys, what we would really need to do is we would need to verify. Okay, so I think I misspoke a little bit earlier, guys. I just want to show you kind of what I'm doing here. As you can see, all I did was I unplugged that, and I plugged my test light in. And I don't know if you guys can see it, but we see it flickering. And that screen just came to a pause in there. But all I did here, guys, was I just took my test light. It's going to battery positive. And all I did was I back probed it into the control wire of this connector, into this brown wire. This is the wire that goes back to the engine computer. This is the one the engine computer is providing ground side control on. And that test we were in before, the tank vent solenoid valve test, that's one I was just in. I'm going to hit start on that again and watch our test light. So as we can see, the test light's flickering. Let me turn this light off. So we can see the test light flickering, guys. This is a time test, so it's going to time out here in about 10 seconds. We'll watch this until that happens. We have about 5 seconds remaining now. And now that test shuts off. So in fact, the test that we were in, guys, this tank vent solenoid valve seal test, that is for the purge solenoid on these. So that's super good to know. I'm just going to hit back on this just to show you this test one more time. This is the test, guys. Actuator test. Tank vent solenoid valve. That is the purge solenoid on this vehicle, guys. It is not the canister vent valve or anything like that. It is the purge solenoid valve. You can find that through both menus, special functions, and actuator tests. So that's definitely some good knowledge for the future, just to know on these. So, I mean, we already know, guys, we have a high resistance purge solenoid, but I just had one show up. So initially what we're going to do is we're going to bench test it. We're going to get a baseline resistance reading on that compared to what we have on this defective one back here. And then we're going to install it in the car. And really that's going to be it. I don't really see any reason to... Actually, you know what? We'll install it on the car and then we'll rerun this actuator test so you can hear it clicking. So that's what we're going to do. Let's do a bench test first. Alright guys, as you can see, I have my meter set up on an ohm scale again. And right here, I have the new purge solenoid that we're going to be putting in this vehicle. So really what I want to do here, guys, I just want to get a comparison resistance measurement of this new one versus the old one, since we didn't really have a specification to go off of. Again, our known bad solenoid, 850,000 ohms. That's high resistance. That's definitely the cause of this open circuit trouble code that we had here. So just going across the terminals of this one, hopefully I'm not blocking you guys' view too bad. Just going across these terminals, our meter's doing some auto ranging, and we have a measurement now. 25 ohms is what we're looking at, guys. That's about more what I expected. A number I used earlier in the vehicle, or earlier in the video, 10 to 50 ohms. That's 50 ohms. That's typically what I see on solenoids like this. As we can see on this known good one, 25 ohms is what we got. So what we're going to do, guys, we're going to put this known good solenoid in the vehicle, and we're going to rerun that actuator test, and we're going to hear this bad boy clicking its little heart out, unlike the one that is currently in the vehicle. So let me get that done, and we'll do the confirmation. All right, guys, so we got the new purge solenoid installed here. And I'm just going to remove my test light out of this connector. I'm just going to replug this back in. Might as well go ahead and snap this cover back down into place here as well. Just getting this connector pushed back on here. There we go, right as rain. And really what we're going to do at this point, guys, is we're going to revisit this functional test we had on the scan tool. And we're going to see how it responds now. What we should hear with this good solenoid and what we did not hear before was clicking as the solenoid is quickly commanded on and off. So I'm just going to go back to actuator tests. And the one I'm looking for here, again, tank vent solenoid valve. That is the purge solenoid on this vehicle. So our ignition is on. Just hitting continue on that. And then we're going to hit the start key up here at the top left. Hopefully you guys can see that. So hitting start now. I want you guys to listen. Not sure if that's picking up. I'm going to hold my mic closer. But this solenoid's definitely moving now, guys. It's definitely being energized. We definitely hear clicking on this. So without a doubt, this is a fix. You know, it's a complete 180 of what we had before, guys, you know, without a doubt. So, you know, this is pretty simple to troubleshoot. I'm glad that we kind of went after this tank vent solenoid valve functional test a little bit more, just so we could really determine what that was. We learned a lot about this evap system for sure, too. You know, it does use a leak detection pump. But all in all, guys, really what this was it was just kind of an easy 2-wire solenoid, you know, diagnosis. That's really all it was. You know, this is a ground side switched solenoid that is fed power from a fuse. Testing it on this vehicle is really no different than any other. Again, the trouble code we were dealing with is a purge solenoid open circuit fault. And you know, we basically just used some fundamental techniques to troubleshoot this. You know, really the methods that we used in troubleshooting this vehicle can be applied to really any 2-wire solenoid design. So nothing really too special about it, guys. It's more just some reinforcement on testing a 2-wire solenoid. You know, testing a 2-wire ignition coil, a 2-wire fuel injector, you know, a 2-wire vent solenoid. Really, it's all no different. The fundamentals still apply. And really all you need to know is if it's ground side switched or power side switched. But as for this one, open circuit fault code caused by a high resistance solenoid. As far as a known good specification on this that we were able to grab using the new purge solenoid, 25 ohms is what we had on the new one. The old bad one, we had about 850,000 ohms. So as far as the fix goes, guys, that's it. We got the new valve in. We have confirmed that it works. And really there's nothing else to beat up on this one. So if there's any questions pertaining to this issue, guys, or any other issue, leave them down in the comments and I'll be happy to answer them. But that's it for this one, guys. Thanks for watching.